The team is back with another episode of Topical Explainers, the first chapter of CAI IGCSE Computer Science. In this video, we will be discussing all about number representation, which comes under the chapter of data representation. And to simplify the topic and provide us with all the information needed, we have Abdullah with us here today.
Hello everyone, my name is Abdullah Amir and I am a student in A2 which is studying computer science. I have written the IGCSE Computer Science notes for ZNotes and currently I am also a video content creator for the Computer Science IGCSE syllabus. And so let's just go right in and go into the data representation chapter. This is the chapter number 1 of the syllabus, and this is the first topic of the chapter is number representation. And it's pretty simple, so I think it would not be taking too much of our time. So without wasting any time, I think we should just straight away go deep dive into it. So number systems is the first thing about that we need to just make sure that we have a strong grip upon, because this part will be taking us ahead into the topic. And if we are missing anything in this part, our base will not be fully covered and we will be missing a lot of part in the future. So basic things first, binary system is the main system as a computer uses. It is a base 2 number system, which means it can only have two values, 0 and 1. Any other number could not be represented. If we're referring to a value being off, it will be 0. And something is on, it will be 1. One thing to be noted is that I have used the word bit for a binary value a lot. And this is due to the fact that bit will be taught to you later, but to be able to explain this part, bit is the smallest piece of information that could be given to a computer. So that is 0 or 1, off or on. So just keep that in mind that bit will be one binary value. That's what we'll be referring. But byte will be 8 binary values, which is the most of the computer deals with. We'll explain the whole bit byte part later on the next video. But for now, I think you just need to know this so that we could be able to carry on with this topic. So one thing to be noted is that the MSB, the most left bit in a system when we've written a number of bits together, will be the left one. So if there's a value which has the binary value 10110, let's just say these 5 bits are referring to one number or one value, this one would be the most significant bit. This is due to the fact that if we accidentally shift this 0 to 1, the value would of course change, but the effect on the change of the value would be not that much. Only a slight change will be noticed. But if we change this one, the change in the value would be very significant. So we will be having problems, a much larger problems, making it the most significant bit. Now, going on to the denary system. Denary system is a system that we use nowadays. The basic number system that we have learned in math, 0 to 9, and all of these numbers are used in any other number we use. Let's just say 20, 54. Any number that we use have any of these 9 values that we use to create the final value. And denary system we're all familiar with. That is our own number system. Hexadecimal number system is the base 16 number system, which has 16 values. So the 0 to 9 value would be the denary number value, which is the basic value that we have learned. And A to F would be 10, 11, so on until 15. So A would be 10, B would be 11, C would be 12. So we'll have values till 15. So if there is a number that is 24 in denary, it will not be 24 in hexadecimal. It would need to be converted. We'll show you the conversion in this episode and how we convert a number from one system to another. So let's just go right in. Just one more thing I think I need to tell you guys that there is another system that you might have heard, octagon, which has 8 bits, 8 values. So that system is not in the IGCSE syllabus, so we'll not be talking about it. So going straight into the binary and denary conversion. So if you will look at it, let me just have a laser pointer so that's very easy for you guys to look at. So if you look at this box, whenever we're taking a binary value, for this example, we have this binary value, which is also in the ZNotes. We have to make a table. I think this is the most efficient way of doing this. So this table is of 1 byte, as I said, 8 bits. The system is pretty simple: 1, 2, 4, 8, 16, 32, 64, 128. You can memorize these numbers, just like multiplying each number by 2 But the thing is that this is the value of 2 and their powers: 2 raised to power 0, 2 raised to power 1, 2, 3, 4, 5, 6, and so on. So let's just say we have more than 8 bits. We can extend the table. For example, if we have 11 bits, we'll add 2, 5, 6, which is 2 raised to power 8, and so on. So we do it like that. Going ahead, now one thing else which we could do, which we have to do here, is that now we put the binary values in. Keep in mind that we have to start from the right side. So the most right bit is 0, so we put 0, 1, 1, 1, 0, 1, 1, 1. So when we put the values from the binary value into the table, we'll notice that some values, like say 128, 64, and 32, have ones below them, and some have 0. Every single value that has 1 below them, that will be added together. So 128 has a 1, 64 has a 1, 32 has a 1, 8 has a 1, 4 has a 1, and 2 has a 1. So we just add them all together and we have 238. So this binary value that we just had is 238 in general. So if we get a binary value, we will easily convert it into denary. Now talking about denary to binary. So let's just say we have a denary value. One thing we could definitely do is try to reverse this method. We have a number in binary. We could, like the way we convert binary to denary, we use mental math. And let's just say, for example, we have 238. We could say, okay, if I add 128 and 64 and 32, and then 8 and then 4 and 2, we could get 238. But that method is very better if you have a good mental math skill and your math is good. Or else you could use this simple method. I prefer this method more. And even in my CAI exams, I use this method. So you could use this method or that method, but I would be going over this method more. So you start with a number. In this example, we have 142. You take 142 and divide it by 2. That would be 71. Why are we dividing this by 2? Because this is base. This is the base number of binary. So 71 divided by 2, 35. Ramesh, if you could help me a bit here and let me know what are the next values.
Sure, yeah. So like when we divide 35 by 2, we get 17 and with the remainder of 1. And then we divide it again by 2, so we would get 8 again with the remainder of 1. But then when we divide 8 by 2, we get 4, which leaves no remainder. And again, we divide it by 2, so it's going to be 2 with 0 remainder. Then divided by 2 again, which would give us 1 with 0 remainder. And 1 in itself would give us a remainder of 1 for final digit, final
Yeah,
bit.
thank you very much, man. Thank you very much. So when we're done with this, you'll see we have a whole table of remainder there. This thing would not be mattering to us a lot. But if we go into the right, 1 0 0 0 1 1 0. So we go from the bottom and go up. 1 0 0 0 1 1 1 0. This is your binary value. 1 0 triple 0 triple 1 0. This is now converted. 142 in binary is this. So whenever you get a binary value, you could do this. And if you have a time in your exam, you have doing one conversion, for example, binary to denary, you could reconvert it. 238, you could reconvert to the binary value to recheck this. And this one you could reconvert using the other method back towards denary and recheck it if you have time. I usually do it at the end of exam. Like if I have time at the end, I would recheck it. It's all up to you, but I would definitely recommend that if you have time, do recheck. Now going to hexadecimal to binary. So this is where it starts to get a bit tricky because hexadecimal is now getting involved. So separate each value from each other and convert them to denary. If you could just get a quick recap of how to convert a denary from Ramesh.
Sure. So if we're trying to convert any hexadecimal into denary, right? So we first of all convert hexadecimals into binary, right? Wait, for hexadecimals to denary, it's just simple as changing the values. Like let's say, so 0 to 9, they're gonna have the same exact translation. But when we're talking about like A to F, then they have their respective values in denary. Like let's say A is 10 and F is 15. So like in this case, F here would give us 15 directly, and D would give us 13 in denary, looking at the chart. And then after that, it's simple as converting those denary values into binary individually and keeping them separate as 4 bits of information, which is also known as a nibble. So in the first example, 2 is basically 0010. 1 would be 0001. 15 would be 8. Either there are actually two options that we could do. Either we could divide it by 2 and find the remainders, or it's just a small value here, so we could just see what fits in. So like 8, yes. And if we take 8, that would be the first bit would be 1. Then after that we have 7 more. So would 4 count? Yeah, sure. We have enough space. So it'll be 1 1. Again, now when we take 7 minus 4, that'll be 3. And do we have space for 2? Yes. So that's another third bit 1. And then after that, we have a remaining 1, which goes in there. So 15 would just basically translate to 1111. And then we have 13. And in that case, we do the same process over again. 8 is there. Yes. So when we do 13 minus 8, that would be 5. So 1 bit 1. Then the second bit would be we have 5 remaining, right? Do we have space for 4? Yes. So we can do 5 minus 4. That would give us 1. Okay. The second bit is also 1 now. And now the remaining is 1. So we can't exactly put a 2 there. So in the third bit, it'll be a 0. And in the fourth bit, it'll be 1. So 13 would just give us 1101. And then finally, to sum it up, we could just put them together.
Yes. So what Ramesh basically did, I'll just tell you, just to make it a bit easier, that he converted 15 and 13 into binary using the other method, the mental math method. So 4 bits, 1, 2, 4, 8. So he subtracted 8 from 15, and then he subtracted 4, then he subtracted 2, and then he subtracted 1 to make it a 0. So you can definitely use that method. If you're not comfortable with it, you can use the method that I just told you. But at the end, you have to make it in the groups of 4. And for example, if your answer is 1 0, you have to put zeros, 2 zeros at the start. So you make sure in mind that you're putting 4 bits for every value. So at the end, we'll be using 0 0 1, 4 zeros, 1 2 3 4 5 6 7 1 0, and then a 1. So we'll be combining each of those 4 bits or nibbles together. And one more thing, like if just say your answer does not have the space for these two values, so you'll be removing the most significant bits if those are zeros, because these zeros are worthless if they are before a 1. If they're on the right, they have value, they have worth. But if they're on the left, they are worthless. Now going to the binary to hexadecimal part, this goes a bit more even more confusing. So we're just doing the same old value, 21FD, 21FD. So we cannot call it 21FD, we have to call it 21FD. So same value, but we're converting it back for a better example. So this is our given value. Now we make it onto the groups of 4, starting from the right. So 1101, then we have 4 ones, then we have 0001. Now we have 10, which is the two leftover values. So we'll add 20 on the left to make it easier for us to understand. Now, the same way that we have done to convert to January, binary to January, we've just learned that. We could convert these values to January to 1, 15, and 13. And make sure these values have to stay separate from each other. 2 is different, 1 is different, 15 is different, 13 is different. And this is not the binary conversion of this binary value. This is a binary conversion of each of these nibbles separated, which we will do. So then we have 2, so we go 2 straight away, 1, 1, F, 15, and 13D. So actually what we're doing is, we're dealing each binary value separately rather than as a whole. But that makes it pretty much confusing. So that's what we do for binary and hexadecimal. Now hexadecimal to binary and binary to hexadecimal. So hexadecimal to binary and binary to hexadecimal gets a bit confusing. So what I would recommend is that we know how to convert binary and hexadecimal, both of these values, to binary. So I would recommend that we just simply go into the binary bar and then take it onto hexadecimal or binary as the question requires. One method that we do to convert from binary to hexadecimal is that we take the value and divide it by 16. And then take the remainders just like the 2 part. But you don't have a calculator in the exam, and you cannot just have the 16 stable, memorize it in mind. That is going to be very tough. So I would recommend that you use this method. It shouldn't be taking you a lot of time when you have a good amount of practice. Addition of binary. Okay, so this is a bit even more confusing part because it has been added new into the syllabus. But if we just go into it slowly and focus, I think we will be able to do this. So whenever we're writing binary, we cannot, for example, 1 and 1, we cannot write 2 as if we do in our basic math, the binary math, because 2 is not existing in binary. So let's just say we have 0 and 0, we get a 0. When we add 1 and a 0, or 0 and 1, in the easy words, between 1 and a 0, we get 1. And this is where it gets confusing. When we're adding two ones, I'll show you even clearer in the next example. We have a 0. 1 and 1, adding them would give us a 0, but we'll be taking 1 carry to the next value. Then we have three ones. Then our answer will be 1, and 1 1 will also be taken as a carry to the next value. And then we have the overflow bit. Overflow bit is the bit that has exceeded the limit. So that bit, for example, as I said, we have byte. So 8 bits is the major way that we deal with values. And sometimes what happens is that when we're doing processing, we'll discuss later on about the memories. So in memory, sometimes the memory does not have the space for the ninth bit. So the ninth bit has to be given away, has to be lost, which is the most significant bit. So that bit is overflow. So doing an addition, sometimes we will get an overflow bit, and that bit will be lost. So let's go to the example. So let's just talk with the example. We have two binary values: 110, 111, and 110, 4 ones and a 0. So if we add them, we just write them from the right side. So this is the part that means right now to us. The rest of the parts are just there for example. Let me just make it more clearer for you guys. So this is the basic part that we'll be dealing with. The upper part is the carry, which we'll be going right now. So if we had 0 and a 0, we get 0, as I said, from the points to node part. When we had 1 and a 1, we'll be getting a 0, and 1 will be going as a carry. So now we have 1, 1, 1. So if we add 3 1, we'll get another 1. And then if we add this one, will go carry, triple 1, once again 1, 1 carry, 1 plus 1, we get 0, 1 carry, 1 plus 1, 0, 1 carry, triple 1's 1. Now this is the confusing part. Now as we have triple 1, we'll be taking 1 as the answer to this line, and we take 1 carry. Adding 1 and a 1 would be giving us 0, but 1 has to go carry. Now this is the ninth bit. What can we do here to fix it? Because our 8 bits are complete. This is our answer. So the carry bit, as it has nothing to be added to, is just written like this. This is 1 is just written there. And this is to be known as the overflow bit. Now this bit, when we are given the answer, if we will just look at the end, it's written in the brackets like this way. So this is how you do it. Pretty simple. And if you have a good amount of practice, we will easily add two values and not pretty confusing. So that is the part of the number systems, the basic part of number systems. So let's just go into the workout session and do the questions. And as Ramesh has been in this episode with us, so Ramesh will be guiding me in the workout part, and I'll be solving the questions, but he dictates what.
So here the question asks us to convert the denary value of 57 from denary to binary. So there are two methods of doing this. Either we can do it by the remainder method, or we could do it by using our mental maths and solving this issue, this question. I would personally use the maths version. So here I know that 57, right? I'm just gonna create a small table of 128, 64, 32, 16, 8, 4, 2 to make it simple.
Yep. Yes, we will use a table. So Ramesh, now what?
So now what we can see is that 57, right? The smallest value, like any value that's lower than that, we can see that it's 32 definitely. Because if we try to put 64, we know that 64 is more than 57. So we would put a 1 at 32, right? And then after that, when we do 57 minus 32, we get a remainder of 20, 25 to be exact. And so then what comes after 25? We could also put a 1 in 16. And so that would give us 25 minus 16. That should be 9. And then again, we have an 8 there too. So we could also put that as 1. So it's now 9 minus 8. So that would give us 1. And 1 would just go into the first most right digit. And then after that, we just replace everything with zeros.
And here we have our answer. So it's pretty simple now. We have 0, 0, 1, 1, 1. Mind the handwriting. I am using my computer, so my handwriting is pretty bad right now. But this is our answer. You could write it this way as well. Some people prefer to write it this way. This just indicates that you're writing in base 2. But the thing to notice that if you're using this method or the method that I've told you before, the remainder method, you have to show the working because it is asking you to show your working. And if you just write the answer, you will just do 1 out of 2. You will not be getting the second mark. You have to show your working, so you'll get both the mark. If there's a you could call a silly mistake in your working, you will lose a 1 mark. For example, there had to be 1 here and you accidentally made a 0, you will just lose 1 mark. But if there is, if you just forgot to do the working and you simply wrote the answer and you did the working in your mind, you'll be using 1 mark. Now going to the D part of this question, where we're skipping the other part, because it's not in the what we've learned yet. Where the other parts we'll be teaching you guys later.
Yeah,
Ramesh.
so with this question, right, it says to convert the binary integer to hexadecimal. Okay, so here the method I would actually personally use is convert the binary into denary and then the denary into hexadecimal, right? And actually, wait, no, sorry, never mind. So the binary value in itself would actually convert into hexadecimals by just dividing into 2 nibbles, which is basically 4-digit binary, bits of binary. And so, using them as separate values, we could actually convert them directly into hexadecimals. So, looking at the first nibble, which is 0011, we convert that into hexadecimal, denary first of all. It'll be 2 plus 1, which is basically 3 in denary. And 3 in denary is equivalent to 3 in hexadecimal, so we can keep it as that. And then we have 1010 as the second nibble. And here we could do 8 plus 2, because that's the values of 1 where they are. That would give us 10 in denary. But 10 in denary is not 10 in hexadecimal. So what we have to do for that is that we have to map. Need to know what 10 is, and 10 in hexadecimals is an A. So the final value of the translation would be 3A. Yeah.
The thing
Basics.
that I'm writing in the bottom, the 16 and 10. So I actually just used to write this just to clarify my answer that this is the final answer. You could just, but I also seen my classmates do, they just put an error just to indicate it's the final answer, not the working. So you could do that. You could do this method, but I would recommend that you indicate this is the final answer, so the examiner does not get confused. Now
Yeah.
on to this one. This question is from another paper. If we just go to the presentation first, this is from Winter 2018, paper 1-1. And so we were just talking with this question. So Vimesh, I would love to have you again with this one.
Sure, yeah, we could go back to the whiteboard, and here it says that the 6 binary or hexadecimals, we have to basically map them into their denary conversions. So looking at the first value, we've got on 0 1 0 0 1 0 1 1, and this is binary, right? So what I would do is that I would immediately start drawing the table on top of it just to know what the positions are. But with enough experience, what we can say is that I'm going to look at the leftmost. Okay, it's 0, so not 128. So, but the second digit it's 1, so it's going to be 64 plus, and then 32 is not there, 16 is not there, but 8 is, right. So it'll be 64 plus 8. Then 4 is not there, but 2 is, So it'll be plus 2, and then plus 1 is also there, so 1, 2. And that would, and we have to just basically sum it up. That would give us
75.
75. Yeah.
So just we sorry to interrupt him, but just I'm going to tell you guys a very quick technique for mental math. So which I actually learned from my father. So it's pretty simple. If we just try to complete the tens. So try to make a 10 as quickly as possible. 8 plus 2 would give you a 10. And then you try to make 60 plus 10, 70. And then you have 4 plus 1, 5, 75. So this is a very good trick that I've learned from my father. And this increases your speed in the mental math. If you want to do this, you could definitely do that.
Yeah, this is
So
actually
sorry
very
back to you,
common
Umesh.
to. Oh, don't worry. It's also very common, especially if you have like a lot of numbers, like especially like 16 plus 4, 8 plus 2, 64 plus 16. There are like multiple of these kind of ones that like give like direct numbers. So it's just easier if you have a lot of calculations. Now, looking at the second value, it is 4e. It's a hexadecimal value that we have to convert into denary, right? So again, what we can do is that separate them into two distinct numbers, and then we convert that into binary. Denary first, and then binary. So the 4 would be at 4 in itself, and e would be the value 14, right? So we convert that separately into binary if we want. So 4 would be 0100.
So with enough experience, you will just have all of these first four
Yeah,
nibbles memorized in your head, and just as I'm doing A levels, having these nibbles memorized in your mind is going to be a big lifesaver for you guys. So if you guys
yeah.
could just have a lot of questions and memorize it, it's going to be very good for you.
It's yeah, especially the first four, it's quite easy. And then the next value, it's 14. And so I'm gonna use my old trick again, okay? I'm gonna look at all the four nibbles, all the four bits in the nibble, which is 8, 4, 2, 1, right? So does 8 go into 14? Yes, it's less than that. So 1. 14 minus 8 would give us 6. Now then we have next 4. Does 4 go? Yes. So 6 minus 4 is 2. And does 2 go into? Yes. So 2 minus 2. So we would also put another one there. So 2 minus 2 would give us 0. So we don't have anything after that. So this would give us the binary value of 4e. And then after that, we would convert this into
Sorry to
denary.
interrupt you. Sorry to interrupt you, Umesh, but I just also like to give you one trick here. And I think if we could also use that. So with E, we know it's 14. So when we will be adding this, we'll be adding this whole other bit. So rather than converting 14 back into binary, we will just write 14 and add this into 16, 32, 64, and 128. But if that's a bit confusing for you guys, you can just simply convert it into binary and do it as a whole. But we can also do it that 14 would be for the writer part. This would be 16, 32, 64, 128. So, sorry, back to you, Vimesh.
Oh yeah, no worries at all. That actually does make sense because the first four bits you could easily calculate immediately, right? And then after that you got 16, 32, and 64 is a 1, right? So it would be basically 64 plus 14, which is
78.
equal to 78.
So, let's just see the question. Do we have 75? Do we have 78? Yes, we have 75. This is 75. 78. In these type of questions, you have less chance of missing the answers because there are specific answers that you could only meet. So, the chance of making
Yeah,
a mistake are also very less.
true. And now with the next question, it's a denary again, right? So again, we have to have the mental maths enough to be able to draw the table for binary 128, 64, 32, blah, blah, blah. So in this case, the first digit, it's an 8. Let's just count ones, okay, just to make sure. It's an 8-digit binary value, right? So we know it's going to start with 128. So that's a 1. Then there's another 64. The third digit from the left is 0, so we're not going to count that. That's 32 gone. And now we have 16. That's a 1, right? Then the fifth digit is also 1, so plus 8. Then the seventh digit is 1, which is 2, and that would give us the values. And then after that, we have to sum it up. So again, as Abdullah said, we could use the ones that perfectly align, like 64 plus 16, 8 plus 2. So 64
Yeah,
plus
so
16 would give us
using
80.
that trick. Using that trick, we're looking
Yeah.
at 10. This would be giving us 70, 80. 80
80,
plus 10 would be 90. 90
90
plus 128, well, which is
would
going
be
to 208.
218.
218, yes. 218.
Yeah.
So now we should be checking the answer list, and there you go. You have 218. This is 218.
Right.
And this values will not be crossing 256, oh sorry, 255. The maximum value we can achieve in 8 bits will be 255. So if all of those bits are 1, the answer is 255. And if all of them are 0 and the bit next to them on the left, if there is 1, it will be 1, it will be 256.
Yeah. So with the next value now, we again do the same strat. First value from the left, it's a 1, so it's 128. The second value, no. The third value, no. So like 64 and 32 are gone. Now we have 16. Then we have 8. Then we have 4. 2 is not there. And 1 is there. So that will give us values. And then we basically sum it up. 16 plus 4, 20. 20 plus 8 plus 1, 29. So it's 128 plus 29. So that will give us 159. Wait, yeah, 157, sorry, 157, I think.
And we'll see our answers. There you go, we've got 157.
Yeah.
So done. Now we have
That
2
works.
answers remaining. So we'll just be doing 87 or 19, or 119. I think we should be doing 19 first. Convert that,
Oh,
and
yeah,
87
sure.
will be the one that's left.
Also, wait, we
So
could actually do 87 first. I could also show another technique of doing this.
yeah, we could do that. But just before we do it, I just want to let you guys know, if you see 19 and you see a 19 option on the right side, just don't add it. Just don't say 19 is equal to 19. It is not. In hexadecimal, after the first 9 values, the values are different. So
True.
please,
Yeah.
please remember to convert them. So
Okay.
let's go with the A7 first.
So A7, right? You remember how we had with binary, how we had like 1, 2, 4, 8, 16, 32, right? Like similarly with base 16 values, we have the same table for that, but it's 1, 16, 256, and so on, which is basically the powers of 16, like 16 to the power 0, 16 to the power 1, 16 to the power 2, right? It's similar to how we convert from denary to binary, right? So instead of converting from hexadecimal to binary and then to denary, we could also do it the direct way. So I don't think so you need to memorize anything after 256. Like that's a maximum they might actually ask you, I think.
Could
But
you help me complete the table, because I have never used this method before.
okay. And 256 here. I don't think so
So
that's exactly necessary, the third digit, but like we could just put a we just
like
basically
this,
need to
am I doing it right?
Yeah, that's completely correct. So we're just gonna put the values of 8 and 7 in their respective places. So 8 in itself has a value of 10, right? So in the second, in the middle one, underneath 16, we could put 10.
Like this.
And then we're gonna have the 7 value, 7 as it is 7 on the underneath one, right? And you remember how we did it with binary? We basically multiplied both the values. So in that same case, what we're gonna do is we're gonna do 16 times 10, and then 1 times 7, and we're gonna both add that both together. Plus 7. So that would give us 167.
And in this case, this method has proven to be shorter than the other methods. So you never know what method is helping you. And this time around, this method is very smaller. The
Yeah.
board looks very messy, but A7 is now 167. 19 should be 25, but we'll just do 19 just to be able for a good explanation.
Yeah. So looking at 19, it's obviously a hexadecimal. It's already stated before. And we can actually use the same strat that we used before. So we could use, again, the 256, 16, and 1 table again. So looking at the left digit, right, it's going to be times 16. Let's just draw a table just to make sure.
Yep.
and then 1.
There you go.
And so underneath 16, there's going to be 1. And underneath 1, there's going to be 9, right? And so we just need to multiply it. So it'll be 16 plus 9, which is equal to 5. Sorry, yeah, 25.
And we're done.
Yeah.
So pretty simple. And if you use the other method, you'll get 25 for this one and 167 for the other one. So don't need to be thinking that one method is right for one person. But all of the methods will work. You just have to see what suits you better. And if you suit if the Ramesh's method is suiting you, you can do his method. If my method is suiting you, you can do my method. It actually just depends upon you. So actually, that is it from us. If you will just go back to the presentation, and yep, that is it from me.
Okay. Thank you for tuning in. Yeah, we hope you had a great understanding of the concept. You can get hold of the notes on the ZNotes website, and our social media handles are on display. So connect with us. Feel free to drop any kind of questions you might have. And yeah, see you later in the next upload.